this video, we're going to explore the very specific problem of determining if a set of points is linear. We're going to start off with a picture to make sure we understand the problem. And we're going to start off with my line tool here. And I've got 3 points, and we want to determine if they're linear. So the first thing we're going to be interested in is the slope between the first 2 points, and then the slope between the second 2 points. And if those slopes are the same, then indeed they are linear. In contrast, over here, if we look at the slope of the first 2 and the slope of the second 2, we notice they're different, and so we don't have a single line that all 3 of these lie on, because we've got that bend in there. So the most important thing right now is to remember that if it's linear, all slopes are the same. All right. So let's take a look at a problem like this. Now this is often how problems look in earlier courses. They're made to be so simple. They're like, oh yeah, I go up by 5, I go up by 5, I go up by 5. I see the pattern there, and then here I can see, oh, I go down by 9, down by 9, down by 9, and you can easily see, yes, it's linear, because you can see you have a constant slope of -9 over 5. Remember, slope is delta y, change in y over change in x. So that would be -9 over 5. This kind of problem leads you to think that you have to have your x's always evenly spaced. But we're going to have problems that might look like this, where our x's are not all evenly spaced. Where right here we're going up by, let's see, it looks like 27. And here, let's see, 95 minus 59. That'd be going up by 36, and then to 12 minus 95, that looks like I'm going up by, let's see, 117. All right, so you might think, well, it's not linear because I'm not going up by the same amount, but I have to check the slopes, and so I need to look at what's happening to my y's. So here I'm going up by 15, here I'm going up by 20, and here I'm going up by 65. So let's check out. We have 3 slopes that we need to check out. Slope number 1 is 15 over 27. Slope number 2 is 20 over 36. And slope number 3 equals 65 over 117. Now, to determine if these fractions are equal, I have 2 options. I could change them all to decimals on my calculator, see if they're the same, or I could reduce my fractions. I feel like these don't look too bad to do by reducing. So 15 and 27 are both divisible by 3, so I've got 5 over 9. Over here, let's see, these are both divisible by 4. 20 divided by 4 is 5. 36 divided by 4 is 9. Hey, this is looking good. They're the same. And I'm thinking it might be 5/9 again. So if I take 65 divided by 5, I get 13. So I'm actually dividing by 13 on this one. This one might not be as obvious, but I'm dividing them both by 13. And when I do that, I also get 5 over 9. Now, if you'd gone the calculator route, you would have gotten 0.5 repeating on all 3 of these and would have been able to see, oh yeah, they're all the same. So does a linear equation relate these values? Yes. Why? Because the slopes are all equal. Now I don't want you to leave here thinking that every single problem is going to turn out to be linear. But certainly in a test situation, whether it's linear or not, we're going to be looking for this work that you calculated these slopes. So let's look at one more. Here we've got 3 points, so we're going to be calculating 2 slopes, the slope between these 2 points and between these 2 points. So let's look at what happens to our x. Here we go up by 12, and over here I'm going up by 16. We now know that this is not a cause for concern. Down here I'm going up by 10, and then I'm going up by 12. So let's look at our slopes. Slope number 1, I have my change in y is 10, my change in x is 12, and I can just reduce that fraction, 5 over 6. Slope number 2, My change in y is 12. My change in x is 16, which equals, let's see, I can reduce that, 3/4. These are not equal. If you want to check on your calculator, you can. 3/4 is 0.75. And let's see, 5/6, I believe, is about 0.83 repeating. So there we go. And so we can see that they're not the same. They're a little bit close, but they're not the same, which is why just I'm plotting the points you might not be able to see for sure, because the slopes are kind of close. But our answer here would be not linear because we have different slopes. All right, that's it for this type of problem.